This project allows the viewing and logging of the performance data of both a battery and a load of a system. It uses the standard XT90 connector, which is used with almost all e-bike batteries as well as e-bike controllers. In my case, I'm using this connected to an inverter, which powers my electric blanket. I use this system to view how much power I've used and how much is remaining in my battery. It also protects the battery from overcurrent and undervoltage. This means that I don't have to lay awake viewing the battery voltage in order to protect it from draining too much power out of the battery. It also keeps me safe because I can sleep with the electric blanket on and not worry about the battery overheating or the inverter overheating. There's an LED for the status, which fades in whenever the battery is being charged and out whenever there's a load drawing current out of the battery, as well as a protect LED, which tells you whenever there's been a protect event like overcurrent, under temperature, over temperature, or under voltage. At a high level, all it really does is just bridge analog signals to CAN, and then I use my RVschwarzenegger Bluetooth in order to stream CAN data over Bluetooth to my Android app. The hardware architecture of the system is centered around the Hercules MCU from TI. This is a safety processor, which means that it has redundancy and allows for safe execution. I use a high side architecture, which means that the load always gets the ground directly from the battery. It also supports up to 5,000 watts continuous, as well as monitoring of voltage, current, and power at all times. It has a 500 kilohertz sampling rate, so I can pull in an overload condition extremely quickly. It also allows for soft start as well as soft stop for inductive loads. This means less spark on hot disconnect as well as hot connect, and it also allows for hot swapping. It has 13 thermocouple channels as well as 3 thermistor channels. In the case of this system, I only use one thermistor in order to view the PCB heatsink temperature. For bigger systems, you could use 13 Type K thermocouples in order to view temperatures around the system. The system's working voltage is 36 volts all the way to 60. I use 14S battery packs, which go up to 58.8 volts. You can see that the system has the LEDs on the front. On the side is the DB9 for CAN bus, and then on the other side is the connections for power as well as the load. I will now show how I use the system with my inverter and electric blanket. So you can see I first connect the battery and then I connect the load. I would then connect the electric blanket to the inverter. I use Pecan Explorer in order to view the CAN signals in real time. From here you can see the real-time ADC data. Here are the temperature channels for PCB temperature as well as the other thermocouples. Here is the real-time discharge data for the load. These are the signals that are logged, which means that they're sent over CAN bus to the dongle that will then send them over Bluetooth to the Android app. You can see it shows the load's current, voltage, and power, as well as the SOC of the battery, which is the state of charge. It also shows the reason why the battery or the system is in protect mode. Under protect, it'll open up the output so that there is no current going to the load. On the bus is also all of the Bluetooth dongles CAN messages, which shows the performance of the Bluetooth dongle. Down at the bottom, Pecan Explorer allows you to view signals in real time in this window. And this makes it really easy to debug. Aside from using Pecan Explorer to view CAN messages in real time. I can also use my talk dongle in order to emulate a terminal over CAN. This allows me to have a terminal interface to the system over CAN. Here you can see I'm using RealTerm in order to terminal into the system and give commands. You can issue a version command which will give you the software and hardware version. You can also do a question mark and it'll tell you all of the commands available. The pack command gives you the properties and performance of a charge and discharge of the system, as well as if there are any protect bits set. Again, all of this is done over CAN bus with a virtual terminal and my talk dongle. The best and most convenient way to talk to the system is using the Android app over Bluetooth. So first you would connect to the Bluetooth device and then hit BMS and it will show you all of the battery management system data. You can see here it shows the pack voltage, current and power, and the battery's state of charge. Since the electric blanket that's plugged into it will turn on and off automatically, you can see the current and power change on the fly. Using the app means that whenever you're in the field, you can easily just use your phone to see the load and battery performance and status.